Okay, today we are going to make a flip chart on the laws of exponents. There are rules when you are multiplying, dividing, and doing a power to a power, when you have zeros in the exponents, ones in the exponent, or a negative number as an exponent. So let's start by taking your paper and folding it in half, hamburger style. Then fold it in half again, the opposite direction, in hamburger style. Open it up and take each edge and fold it in to the center. Fold in both sides so that you end up with a piece of paper that opens up to the center, like so. We're going to cut on the line when we're done. The line that you see here, that crease that you made, I'm not going to cut it right now because I want to be able to copy this for students who can't keep up with taking the notes and just want to watch the video. So there's 3 major rules plus some other side rules that you need to know. The first one is that when you multiply exponents that have the same base, you can make it easier for yourself and just add the exponents. So we're going to write down the names of the 4 rules. First, in the top left box, we'll write the words product rule. Write it nice and neat and put a bubble around it. This is our title. Product means to multiply, so I'm going to make a little note to myself with an arrow underneath the word product. Product means to multiply. Okay? There are 3 different ways we can show multiplication of exponents, and I'm going to use a base of a and exponents of m or n to show the different laws. So doing multiplication, we can write using parentheses, I mean. So I'm going to write my first exponent of a to the m, and my second as a to the n. This just means that my bases are the same, and I'm using 2 different numbers for exponents, whatever they are. Instead of multiplying out a to the m and finding what that is, and then multiplying out a to the n and finding out what that is, and then multiplying the answer together, I'm just going to rewrite the base, and then I'm going to add the exponents together. And then you just need to find the standard form of 1 exponent when you're done. You actually add those exponents together, what they are. And I'll show you some examples when we're done. Another way to show multiplication is to use that dot in the center, and make sure it's not on the bottom where your decimal would be, and make sure it's good and fat too, so that it's easily recognized as multiplication. Using a dot to show multiplication. That means the same thing. Add the exponents. Keep your base, add your exponents. When you're working with algebra, you may see this later on, so I want you to see this in your notes. Sometimes when you use variables, you can just write the numbers next to each other. First exponent, second exponent, with no symbol in between. It means to multiply. So it works the same way. Add the exponents, m plus n. Okay. I'm going to pause the video for a second, and I'm going to draw lines where my creases are so you can see where I'm taking my notes better. Okay, well, it won't pause. I don't know how to pause it, so I'm just going to draw that line real quick. Okay. Now the next rule we're going to talk about in the bottom box here will be the quotient rule. Okay? Quotient rule. Quotient means to divide. So I'm going to make a little notation just like I did before underneath the word quotient with an arrow pointing to the word divide. Quotient means to divide, which is the answer when you divide. So we show this by writing it as a to the m over a to the n equals a to the m minus n. What this means is you can have an exponent as your numerator, an exponent as your denominator. As long as the bases are the same, you can keep the base and just subtract the exponents. And you always subtract the numerator minus the denominator for exponents. So it's always the top one minus the bottom one. Even if you get a negative answer, you still m minus n. The top number minus the bottom number. The third rule we're going to talk about is power rules. This is the power rule. Power rule. Put that in a little bubble. Power in this case is talking about when you're raising an exponent to an exponent. We call that raising a power raised to a power. I'll show you what I mean by that in just a second. Raised to a power. So power rule is a power raised to a power. What that means is you have an exponent. We'll use a to the m again. And we're going to put parentheses around it, and we're going to raise it to another power. So we're going to say this exponent, solve that, and then solve it again using another exponent. It'd be a lot of work to write it out that way, to do whatever a to the m is, and then do whatever that answer is raised to the nth power. So we have a shortcut. Instead of doing all of that, you just keep your base, and you multiply the exponents. As I'm using the dot again to show multiplication. I don't have to. I can write them right next to each other. I'll rewrite it again to show you what I mean by that. You may sometimes see this example as a to the m(n) written like that, and it means to multiply. Variables next to each other mean to multiply, just like over here where we said these variables next to each other, this means to multiply here. The last box we're going to reserve to write some notes about some special rules. We call these the 0, negative, and 1 as an exponent. Zero, negative, and 1 as an exponent rules. Because each one of these has a special rule. I'm going to put my little bubble around that to show that's my title. 0, negative, and 1 as an exponent rules. Okay. Here are my examples. Any base raised to a 0 power will always equal 1. You may remember that from some of the work we did last week already. Any exponent or any base raised to the first power will always be whatever the base was. And this is a tricky one. Any negative exponent, so in this case I'm just going to use -1. Any negative exponent can be rewritten as a fraction. And it will always be 1 in the numerator for just this one. 1 in the numerator, and then your denominator becomes whatever the exponent is, whatever this whole thing is without the negative. So it'd be a to the 1. I'll come back again and show you some more examples of what that means. But what you're doing is turning this into, flipping it over into the reciprocal. Putting it over 1 and then flipping it over and taking the negative away. That's a tricky one to remember. Okay, so now that we have the front done, I want you to go through and color it. I'm going to use 3 different colors. I'm going to use one color to color my titles on all of them, and then I'm going to use 2 colors to represent each of the variables. So whatever I color M, I'm always going to color it M, just so it makes it easier to see. And I'll show you my example that I had already done over here. I want you to make sure your paper looks like this. Okay? I'll stop and I'll do another video for the notes on the inside.